So now that we've looked at some basic vocab, just what a sample space is and how the outcomes are related to an event, let's take a look at our first type of probability, which will be an empirical probability. It's sometimes referred to as an experimental probability or relative frequency. So we're going to perform an experiment repeatedly, so let's say n times, and that we're keeping track of a certain event, and that event, E, occurs R times. Now the empirical probability, which would be denoted by P parentheses E, so notice it's a capital P, and then inside the parentheses is the event you're keeping track of. So this notation is not multiplication or anything like that. We would just verbally say this. This is just a shorthand way of saying the probability of event E. Okay. So that probability will be calculated by computing R, the number of times your event occurs, over N, which is the total number of trials of the experiment. So in your numerator will be the number of times the event you are interested in, how many times it occurred, and then denominator will be how many times you ran your experiment. Okay, so we'll set it up in this fraction, and then normally we will then simplify the fraction. I strongly encourage you though, when you set up your fraction, don't just give me the simplified form, give me the kind of the initial fraction with these counts, and then simplify it if possible. So here's our first example of computing an empirical probability. So in 35 tosses of a coin, let's say we get 23 heads. So we're going to determine the empirical probability of the coin landing heads up. Alright, so we want to compute a probability, so we will use that capital P to indicate that we're going to find the probability. And then inside the parentheses, I'm just going to write the verbal description of what the event is that we're keeping track of. So I'm not going to assign it a capital letter, I'm just going to write in here the description of what we're looking at. So the probability that the coin landed heads up, so then we're going to build this fraction. The denominator will be the total number of trials. So how many times you ran your experiment. So we ran the experiment 35 times, so that'll be in the denominator. And then the numerator will be the count of how many times this thing that we're interested in keeping track of, how many times it occurred. So out of 35 tosses, heads occurred 23 times. So then that forms our probability. And if that could be simplified, we would, but this fraction cannot be simplified, so we're just going to leave it like that. Now sometimes we do take a probability when we're talking about it, we would maybe express it as a decimal or a percent. So just as a reminder about how to go back and forth between those different notations, for this fraction, to convert it to a decimal, you would put in your calculator 23 divided by 35. So this decimal, this is going to be approximately equal to, I'm going to take it out to 3 decimal places, so that'll be 0.65 and then 7, rounding to the nearest thousandth. So that would be the decimal equivalent of this probability. And then we then sometimes express this as a percent. So converting this decimal to a percent, as a reminder, you're going to move the decimal right 2 spots. So then that would then be 65.7%, or if we rounded it to the nearest whole percent, we could just say 66%. Now in this course, we are for the most part going to leave our probability in its fraction form, simplified, but sometimes it's helpful to be able to take it to these other 2 forms. The decimal is particularly helpful if you're trying to compare multiple events and you want to talk about the likelihood of one thing happening versus another thing. It's sometimes a lot easier to compare the decimal versions than it is to compare the fractions, especially if the fractions involve different denominators. It's sometimes hard to gauge which one of the 2 is larger or how much of a separation there is between the 2 fractions. Alright, so in this next example, it says the bar graph shows the results of a student who randomly chose one card from a standard deck of cards. It recorded its suit. Okay, so for a deck of cards, the suits are hearts, diamonds, spades, and clubs. There are the 4 suits. So the student pulled a card out, recorded its suit, put that card back in the deck, reshuffled, and then chose a card again. Okay, so from running this experiment, they have this bar graph. So we're going to find the empirical probability of choosing a card of each suit. Okay, so first let's find the probability of getting the suit of hearts. So the first thing we're going to need to determine is how many times this experiment was run. So it looks like I have 17 outcomes here, 8 outcomes here, 13 here, and 12 here. Okay, so there are going to be 50 trials of this experiment that was run. How many times the experiment was run is in the denominator of the fraction, and then the numerator will be how many times this particular event occurred. So hearts occurred 17 times. And then this fraction cannot be simplified, so I'm just going to leave it like that. What would be the probability, the empirical probability? So these are empirical probabilities because they are counts that result from running an experiment. Okay, so you're actually looking at data to get these numbers. So in this data, out of the 50 trials of the experiment, how many of them were diamonds? It looks like 8, so that'll end up building my numerator. And then this fraction can be simplified, so this looks like 4 over 25. All right, next suit. What's the probability that we get a spade? So 50 trials of the experiment. Notice that I build my denominator first. I always like to kind of keep in mind what were the total number of trials of the experiment, and then out of the trials, then I look at how many of them satisfy the event that I'm keeping track of. So spades then occurred 13 times out of the 50, and then that can't be simplified, so I'm just going to leave it like that. And then finally, the last suit would be getting a club. So out of the 50 trials of the experiment, clubs occurred, it looks like 12 times, and then that can be simplified. So we now just found the empirical probability of choosing a card of each of the possible suits that were recorded from this experiment.